Now let's learn something about image orthorectification. Orthorectification is a process of correcting image space and geometric distortion to generate a multi-center projection image. In addition to correcting the distortion caused by general system factors, it can also correct geometric distortion caused by terrain. For example, if the Earth is flat from this view angle, the satellite will observe point 0 and it will get the information of point 0. And if there is the terrain effect, for example, there is a mountain here. From the view angle, the satellite will observe this point, and this point reflects the information of point 0. So there will distortion between point 0 and point 1, and the image orthorectification can be used to correct the geometric distortion caused by terrain. It can be used to correct the distortion between point 0 and point 1. In the image orthorectification, we will do 2 exercises. The first exercise is RPC orthorectification with ENVI. The satellite sensor models are mathematical models, and these models usually define the physical relationship between image coordinates and ground coordinates. And they're different from each sensor. That is to say, different sensors have different set models. The relational polynomial coefficient, short for RPC, are one type of replacement set model. It will replace the rigorous set model with an approximation of the ground-to-image relationship. And the RPC model, the accuracy of the RPC depends on the accuracy of the original sensor model and the quality of the image. Usually, most models with high resolution, such as QuickBird, usually have the pre-computed RPC information. If we have RPC information, we can automatically derive RPC-based geolocation information for individual pixels in an image. The RPC-based geolocation is not as geographically accurate as performing. In a full orthorectification, but it consumes less memory and disk space. It needs to be noted that RPCs are not the same as a map projection. It's not map projection. Rather, The RPCs relate pixel locations in an image to the corresponding latitude, longitude, and elevation using a third-order rational polynomial of the following form. Like this. The xy is the relationship of latitude, longitude, and elevation. Therefore, to determine the pixel location, the ground point must have the accurate values of latitude, longitude, and elevation. If we don't have the ground elevation, usually the coordinate transform will assume an elevation of 0. So, to ensure more accurate ground coordinates, we need using ground control points to refine the RPC and supply an accurate DEM, that is, digital elevation model. Okay, this is the general introduction of the image orthorectification. Now, let's do the exercise. RPC orthorectification with ENVI, stamp by stamp. Okay, now, at first, let us start the ENVI software. From the start, all programs find ENVI and find the ENVI icon. Click it. Wait. Until the ENVI screen appears, and in the main menu bar, from the file open, from the open as, from the quicker bird, okay, from the quicker bird, and navigate to the file folder named image orthorectification. Click it from the data, and from the quick bird, click it, and from the 005 and so on, click it, and select the TIFF file, and click Open. After opening it, click the Zoom to full extent. We can view the full extent of the image of the quick bird. Of course, if you need more information about it, you can click the Data Manager And in the file information, you can find the file type, the sensor type, the product type, the projection, the wavelength, and so on. Okay, now we click it. And from the file, open in the QuickBoard, from the TIFF file, the DEM subset, and click Open. Now the DEM data will load in the ENVI software. Now let's do the exercise, and from the toolbox, select the geometric correction here. Yes, here. In the drop-down list, we can find the Orthorectification, and we can find the RPC Orthorectification workflow. Yes, because the QuickBoard has the RPC information in it, and double-click it. Now in the RPC Orthorectification, at first we need to select the file, select the input and DEM file. The input file, we select the TIL file, the QuickBoard TIL file, and the DEM file, we select the DEM file. Okay. Now, after select the input file and DEM file, now we need to click Next. We will leave the default setting of the GCPs and statistics, and we will set advanced table and expert table. In the pixel size, we use the default 2.5 meters. It's the resolution of the QuickBoard. And we change the image resampling to the cubic convolution. And in the export, we can select the output file format, the ENVI or the TIFF. We use the ENVI, is okay. Here we can change the output name and give it a directory. For example, we save it in the tab and give it a name of Orthorectification. Orthorectification. Now click it. And if you want to the Orthorectification report, you can click it here. Here we don't need it. And after this setting, select the finish. Click the finish icon and wait. Okay, now the result appear in the lane manager. It's here, named Orthorectification, and we remove the DEM date and zoom them to full extent. How we know we did the Orthorectification? We can use the Porter tool and zoom them. Yes, we can find the Orthorectification is different from the original file. Okay, now the first exercise, RPC Orthorectification, is finished. After it, we need to use the determinant. Select the close all files, click Yes, and click the software. Application, yes. The more information about the detailed operation in the Word file you can find after your class. Okay, now let's begin the second exercise, RPC Orthorectification with ENVI classical version. At first, we need to start the ENVI classic software. From the Start All Program Files, find the ENVI icon in the drop-down list or in the Tools, find the ENVI Classical. Click it. And now we can see the ENVI Classical software in the screen. And from the File in the ENVI menu, File in the drop-down list, find the Open External File, find the QuickBird, and in the drop-down list, find the GeoTIFF, and then click it. Navigate to the file folder I give you. The image Orthorectification, the date, from the QuickBird in this file folder. Select the TIFF file and click Open. Now the TIFF file appears in the available bed list. And then from the File, Open Image File in the QuickBird, select the base image and the DEM file. Click Open. And now we need to relate the DEM information to the reference file, and the base image is the reference file in this exercise. In the file name, right-click and find the ended handle. Click it. And in the header info, find the ended attribute. Click it. And in the drop-down list, find the associate DEM file. And in the select DEM bed to associate with this file, select the DEM subset. Click it. Okay. Now, let us load the base image. At first, select the base image and click the load bed in the available bed list. Click the load bed. It appears in the screen with 3 zoom. And we click it, we right click it from the cursor location. When we move, we can find beside the data there is the DEM value. And now we note the image needed to be warped in a new display. Here, in the display number 1, here, click it, we select a new display. And we use the RGB color to load this TIFF file in the display 2. And we select 4, 3, 2, 4, 3, 2, and load RGB, load the TIFF file in the display 2. And now let's do the Orthorectification. In the map, Orthorectification, find the quick bird, and in the drop-down list, select the Orthorectify quick bird with ground control. Here, it needs us to select a file and the input display. We use display 2 because our image needs to be warped in display 2. And click OK. Now, the ground control point selection appears. And at first, we change the projection. Click the Change Projection here. And change the projection to UTM. And give it 12 zoom. Click OK. Now, we need to select ground control points. We need to select the same name point of the two images. The first one, we can locate the ground control point here. Locate it in the cross point of two rods, and find the corresponding point in the warped image in display 2. It's about here. And locate it correctly. And in the first display, right-click and click the pixel locator in the drop-down list and adjust the cross in order it corresponding to the point in the warped image. After it, export. Click the export in the pixel locator. Click the export. We can find the information is ended in the ground control point selection, and we click Add Point. So the first ground control point is ended. Use the same way, we can find the second point with the same name in the two images. For example, here, it's about here. Yes, it's about here. And use the same way. When they represent the same place, and click Export. The information is also added in the ground control point, and click Endpoint. The second ground control point is ended. Okay, now we delete all the point. In order to save time, we use the prepared GCP points in the data clipboard and select the GCP points. Click Open. Here we can find these selected ground control points. And now we need to also rectify in the ground control point selection. In the option, select the also rectify file, and in the select file to also rectify, select the TIFF file and click OK. Now we need to send Orthorectification parameters. At first, we need to select DEM file. Click it, select the DEM file, and click OK. And now give it a output path. We choose the image Orthorectification and give it a name Orthorectification and click Open. After the parameter setting, click OK. Okay, now we have finished the Orthorectification and close all the files and close the ENVI classical software. And start the ENVI software. Now let us open the base image and open the Orthorectification in the ENVI classical version and click Open. Click the Zoom to full extent and use the Porter tool. We can find now there are no distortions. Okay, now we have accomplished all the operations about image Orthorectification. Now from the determined close all files, click Yes and click the ENVI software. Okay, thank you.